Hi, I'm Pallav from Just Tutors, and today we are going to learn matter in our surrounding. So we have discussed about it and we'll discuss about it more. So these are the points we will learn in this video: evaporation, factors affecting evaporation, and cooling effect of evaporation. So what is evaporation? So evaporation is the process by which the liquid converts to gases, but here it is not occurring on the boiling point, it is occurring below the boiling point. It can also take place at the room temperature. One more important thing here, that evaporation takes place only on the surface of a liquid. And here we can take example of water. So evaporation takes place at the surface of water. It is different from vaporization, because vaporization takes place at the boiling point. Now, how evaporation takes place, or how liquid changes to vapor. We know that the matter particles are always in continuous motion, so and they have kinetic energy. They collide with each other and transfer energy to each other. So in liquid there are a small number of particles at surface having higher kinetic energy. So after collision, when they get higher kinetic energy, higher enough so that they can break the force of attraction between other particles, so they break that force of attraction and converts into the vapor. Now, what are the factors which affect evaporation? What can be the physical factors on which evaporation can depend? So temperature, yes, temperature is evaporation is directly proportional to temperature. As the temperature increases, the evaporation increases, because with temperature the kinetic energy of the particles increases. In the same way, another factor is surface area. So rate of evaporation is again directly proportional to surface area. Good example is our cloth. So when we want to dry our clothes, what do? We spread them, so they get dry quickly. When we spread them, we get higher area. So when we have higher area, so the evaporation takes place fast. The more area is exposed to air, so they dry quickly. So evaporation is directly proportional to surface area. And what if we just put the wet clothes without spreading? Then it will take more time. So by this example we can understand this: the more area, more evaporation. Then another factor is humidity. Rate of evaporation is inversely here proportional. Here it is not directly, it is inversely proportional. Basically, humidity is amount of vapor present in air. So if we have more vapor in the air, so the evaporation will decrease, because if we have more vapor in the air, the holding capacity or water holding capacity of atmosphere will decrease, so the evaporation will not take place fast. So it is inversely proportional to humidity. Dry air can hold more water vapor. And then wind. So this is about speed. The rate of evaporation directly proportional to the wind speed. So when the speed of wind increases, the particles of water vapor start to move away fast, and the amount of water vapor in a particular time which can environment hold or take away from the surface will be more. So it is directly proportional actually. So the evaporation is directly proportional to the speed of wind. Then cooling effect of evaporation. So there is effect of evaporation, that is cooling. So for liquid to evaporate, it needs some energy. So it requires a latent heat of evaporation which it takes from surroundings. It means it is taking heat from surrounding, and if it is taking heat from surrounding, the surrounding will feel cold. So that is the way the cooling effect occurs, or we can say the surrounding loses their energy and cool down. For example, when we sweat and mm, the evaporation takes place, the vapor takes heat from our body and we feel cool. We have some important and common questions which we can think of, like how water inside the earthen pot cools down. So I think we have noticed that the earthen pot has very teeny tiny holes in it throughout the surface, through which water slips out, and this water takes a latent heat from inside, from the liquid, from the water inside it, and evaporates. So now the heat is taken away and the water inside the pot is cooled. And the next question, why do we see water droplets on ice cold glass of water? So when we have ice cold water and the water vapor present in the air comes in contact with the cold glass, they loses their energy and forms water droplet, because vapor has higher energy, liquid has low energy. So when the vapor loses their energy, they becomes water droplet around the glass, or we can say that vapor gets converted into liquid. Now let's see what did we learn. So you can pause the video, try these questions, then we'll move on. I hope you got the answers of these questions, and these are the answers of these questions. These are small hints. So thanks for watching this video. For more you can visit justtutors.com. Thank you.